This video is all about POUs, or Program Organizational Units. POUs are the core of any IEC 61131 program. They consist of programs, functions, and function blocks. And I get asked a lot what the difference is between those three and why you would use one over the other. So let's look at a little explanation. So beginning with the program, it uses dedicated memory and runs in a loop or as a subroutine off the main task. A function block also has dedicated memory, returns multiple variables, and has a separate instance for each. And functions are instantiated inline in the code and have no dedicated memory. Now, just as an example of how these might be used, you can see I've got a program that's running its own separate program looped inside, calls a function block, and uses a function. That looped program could also have function blocks and functions inside, and then you can get very abstract with these and how they're used. First, we'll talk about programs. Every eCockpit new project will have a PLC PRG, which is going to be the main routine. This is going to loop and it's going to already be tied to a task. But for demonstration purposes, I'm going to create another POU here. And in this POU, or in this program, I'm just going to increment a variable just for code demonstration. So we'll do mynum is equal to mynum plus 1. This is a very simple program, obviously, but it's not about the code. Now we'll deploy this to the controller, and you'll notice once we've downloaded and once we click Start, the PLC PRG is looping, but our new program is not. This is because we haven't called it or tied it to a task, so we're going to now just simply go to PLC PRG and call this from the main routine. This is going to loop this every time PLC PRG gets looped by the main task. So we'll log in. We'll run, and you can see now it's green and our variable's incrementing. Next up, functions. So we'll right-click our application, we'll add another POU. We're going to select function at the bottom. We're going to call this tcint f. We're going to select variable type real. We're going to pass this an input variable, so it's going to take our raw input and convert this to a temperature F output. So we'll have a holding variable here as well. So it's not really about the code, right? It's about understanding what the purpose of a function is. So the tcint value, which is a real, is actually a variable. So we're going to make our conversion here with our formula, and then we're going to assign the tcint value based on our holding variable's value. So essentially we're just returning that as a variable. Every time this function gets called, it's going to start with no memory whatsoever, and it's going to apply this formula to the output. So to call it in the program, we just instantiate it inline in the code. We're going to have to create a real variable in our program, which is going to accept the output of the function. You can call the function with an input assistant by clicking F2 or hitting a dot. We'll pull this up as well. And then we want to pass it our input, our thermocouple input. So there we go, we run this, and you can see when we run it, it's called every time, and it's giving us the proper output. And lastly, we'll talk about function blocks. Again, right-click on Application, Create POU. We're going to select function block here. There are lots of options, but we're going to keep it very simple, not extend anything or extend any data types or object-oriented programming. For this, we are going to have two input variables, actually. We're going to have current temperature and maximum temperature. So this is what we're going to argue against for our alarm. We're also going to have an output variable, which is our alarm, which is going to be a bit. And we're going to have an in-out variable, which is our reset. And all we're going to do is we're going to create a variable or an instance of a rising edge trigger, saying that when the temperature reaches the max temperature, when the current temperature meets the max temperature is greater than or equal to the max temperature, then it's going to trigger the alarm high, and we'll be able to reset that alarm with a reset bit, which will trigger high from our program, but our function block will toggle that off. So what's important to know about a function block is a function block needs to be instantiated every time you use it. So you can use these in arrays of function blocks, or you can instantiate every function block on its own in the program, in your program. So when we get close to finishing this here, all of our output variables are in the code itself, so we don't have to create any last assignments there. So we're going to call this, we'll create a comment so we know what it's doing, but we need to now add an instance of this. So we're going to create a variable, and that variable is going to be an instance of our function block. Now we can call this function block in our program with our input assistant by calling an instance of this. So if you look at instances there on the left, call an instance of this, it'll pre-populate all of our fields that we need to fill in. We'll do that with our variables from our program, create some new ones for our alarms and our reset. Now when we run this program, it's using this instance. One of the nice things about function blocks is you can expand them in the variable declaration window and see the behavior of the function block per instance, but you'll see that it's working high here, and we'll toggle our in out. So there you have a general overview of POUs. But like anything else, the way to understand them is to use them. So try different ways of using them. Call programs inside of programs, function blocks inside of programs, function blocks inside of function blocks, and functions all over the place. I'll be happy to answer your questions in the comment section below, and thanks for watching.